Hello everyone. I'm going to be explaining how to solve problem E, that is valid pre-order traversal. So the problem statement says that there is this person named Thar who is given a tree with n nodes and an array of n elements, and our task is to determine whether the array is a valid pre-order traversal of the tree or not. So first, and one more thing, the given tree may or may not be a binary tree. So we'll look at how to perform a pre-order traversal on a tree which is not a binary tree. So in these kind of trees, what happens is there might be a node which has more than two children. For example, 2 here has children 5, 6 and 1. So it has 3 children, whereas 1 here has 1 children, like that will be. So let's pick an arbitrary node in this tree and then perform pre-order traversal using that node as the root. Let's take 3 for example. So we'll write down 3 here. Then in pre-order traversal, first we look at the root node and then we check whether the root node has any children, and if there are children, we traverse the children. So in this case, 3 has a child 2, so we'll write that down. Then 2 has 3 children 6, 5 and 1, so you can traverse any of these children because it's not a binary tree. So we'll traverse 5 first, write down 5. Then from 5 we'll, since 5 has no children, we'll come back to 2, then traverse the remaining children of 2. We can go to 6, and then from 6 back to 2. From 2 we can go to 1. From 1 has only 1 children, so it's 4. So this is a valid pre-order traversal of the tree. There can be many number of valid pre-order traversal. For example, in the same tree, we can, from 3 we can come to 2, then go to 1, then from there 4. I'll write it down in green. 3, 2, 1, 4. Then 4 backtrack to 1, backtrack to 2, then go to 5, and then go to 6. So this one is also a valid pre-order traversal. So now let's look at how the problem is solved. Let's take an example. Let's say 3, 2, 6, 1, 4 and 5. Let's say this is the array which is given to us. So we can start off with the first element of the array, let's say 3. So the first step is to find out the parent of each node. For example, in this tree, the parent of 2 will be 3. I'll store it in an array. Let's say parent of 2 is 3. We can store that in an array. I'm just using parent-child relation here. Then the parent of 5 will be 2. Sorry. Double. Parent of 5 is 2. Then the parent of 6 is also 2. The parent of 1 is 2. And the parent of 4 is 1. So these are also the edges. So how to find these parents? We can start off with the first node in the array, that is 3, and then we can recursively find the parent of each node. For example, from 3 we can go to 2, then say that 3 is the parent of 2. From 2 we can go to 5 and tell that 2 is the parent of 5. Same way we go to 6, tell that 6 is the parent of 2, go to 1, tell that 2 is the parent of 1, and then go to 4 and tell 1 is the parent of 4. We can do that using DFS, a recursive call to DFS. So that's one thing. Then after finding the parents, what we need to do is take the first node in the array, that is 3. Then we need to check whether the next node is actually a child of the present node, the child of the node before it. There's a case when there is a node which is not a child of the node before it. So we'll look at that later. So for now, 2 is a child of 3. So it's there here. So since 2 is a child of 3, we can proceed with our determination. Next we go to 6. Since 6 is a child of 2, we can go to the next node, that is 1. So here 1 is also, oh yeah, 1 is not a child of 6. So what to do in this case? So 6 here has no children. So what we can do is backtrack to 2. If 1 is a child of 2, then we can go. So since 1 is a child of 2, it's fine. We can call it, it's still a valid pre-order traversal so far. Then the next one is 4. Since 4 is a child of 1, it's valid. Now we have 5. So since 5 is not a child of 4, we backtrack again. Go back to 1. So since 1 does not have child 5, we can go back to its ancestor, that is 2. Then since 5 is a child of 2, we can conclude that it is a valid pre-order traversal. So let's look at the other case. What if when the given array is not a valid pre-order traversal? Let's take another example. We'll say that the array is 3, 2, 6, and after that 4, 1, and 5. So this is not a valid pre-order traversal because you have 3, then 2, then 6, and you have 4 which is somewhere else. You can't go from 6 to 4. It won't be a valid pre-order traversal. So what to do in this case? So same way we are going to check. We're going to start from 3, which is the first element of the array. Then go to 2. So since 2 is a child of 3, we can proceed. So then we have 6. So 6 is a child of 2, we can proceed. Now 4, the next element is 4. So what will happen when the next element is 4 is that we are there at 6. So 6 has no children, we come back to 2. So 2 does not have the child 4 in it. It has children 1 and 5. So it's obvious that 4 is not a child of 2. So we go back to 3. And then 3 does not have child 4. So when this happens, the condition where there is a node and none of the ancestors of the previous node, which is 6 in this case, the previous node before 4, that is 6. So 6 does not have any ancestor to which 4 is a child of. So when this happens, we can conclude that the given array is not a valid pre-order traversal of the tree. So I hope you got it here. If you have any questions, you can post it in the group, and make sure that you watch the other videos whose links are provided in the editorials. They are also related to trees and graphs. Will help you. Thank you for watching.